So very good morning, students. So welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th, our ongoing chapter, first chapter, units and measurements. And today we are stepping into session number 2. Means so far we completed one session in knowing about the first chapter of our IIT material, units and measurements. So this is also a part of your regular syllabus. There is nothing new here. There is nothing rocket science. The same thing which is there in your books will be here, but little more extension. So be alert like regular class and attend regularly to get the clear in the concepts, right? So when you move to the further topic, before knowing to know about what we are going to learn today, let us recall what we learned in the last class about this chapter. So we learned about what is the physical quantity, because when you want to know about either units or measurements, the basic thing you want to know is already learned in 6th class also. But thing is, you have to recall, because without knowing the basic foundation, we cannot construct the building. So physical quantities are those which can be measured. The quantities, nothing but magnitude or size, shape. The size, shape, they are called as physical quantities. The quantities which can be measured are called physical quantities. Right? That out of all the physical quantities, only few of them are considered as fundamental physical quantities, and remaining all are comes under derived physical quantities. Right? So physical quantities are classified into fundamental physical quantities, which are also called base physical quantities, and second one is derived physical quantities. Because fundamental physical quantities are those which are independent, which does not depend on any other quantity. They have their own definition. Whereas the derived physical quantities depends on fundamental. They are derived from fundamental physical quantities. Hence, they are called derived physical quantities. So we have seen there are 9 fundamental physical quantities are there. 7 are main and 2 are supplementary. And apart from this 9, remaining all comes under derived. Mass, length, time, these 3 are the basic physical quantities. Area, volume, pressure, density, power, work, energy, all comes under the derived physical quantities. So these physical quantities is always consists of numerical number followed by a standard measurement. Every physical quantity will have a standard measurement. That standard measurement of every physical quantity is called the standard measurement of every physical quantity is called as unit. The very important part of our chapter. A standard measurement of every physical quantity. So we cannot measure a particular physical quantity in the various units. A particular physical quantity will have particular units only. Suppose you want to measure the mass, you have to use the units kg or gram or pound only. We cannot use centimeter, meters, and seconds. Right? So that is called standard. If you go and ask in the vegetable shop, give 2 liters of brinjal, will you give 2 liters? No. You have to ask for 2 kg. That is standard. So every physical quantity, maybe fundamental or maybe derived, all the physical quantities will have a standard measurement. That standard measurement is called unit. So these units are classified. They are having keeping the view of fundamental physical quantities. There are so many system of units came into act, like MKS, FPS, CGS, and international system. That is SI, which is popularly used to go for the business communication with the countries, other countries, right? So that's we discussed in the last class. So what is physical quantities? What are the fundamental physical quantities? We have seen all fundamental physical quantities like mass, length, time, temperature, luminous intensity, electric charge, current, amount of substance. Apart from this, there are two more supplementary are there, which are solid angle and that is plane angle and solid angle. Also included in the fundamental. And the units of fundamental quantities are called fundamental units. Fundamental quantity which are measured in some units. For example, see, mass is measured in kilogram. Mass is called fundamental quantity. Kilogram is called fundamental unit because that is a unit of fundamental quantity. Length is the fundamental quantity. Second is the, meter is the unit, fundamental unit. Like the time, luminous intensity, candela, right? Then derived quantities, the quantities which are obtained from the fundamental quantities. For example, if you ask to find what is the speed you want, speed. What is speed? Speed is nothing but distance by time. We know all. Distance by time. Right? So distance is nothing but length. Time is also fundamental. Length is a fundamental quantity. Time is fundamental quantity. So we are obtaining the speed from both two fundamental quantities. So that's why it's called derived quantity. Pressure, we ask. Support pressure is there. Pressure is nothing but force by area. So force also derived from the fundamental quantities, mass into acceleration. Area also derived from length into breadth. Right? Power is nothing but work by time. All these are derived from the fundamental quantities only. There is no derived units which are obtained individually. That's why they are placed under derived. So like that, there are so many are there, and the units measure. For example, pressure is there. Force is measured in Newton. Newton by meter square. Example I am telling. Newton per meter square is also called Pascal. So like that, there are special units also there for the fundamental quantity. Those quantities are called derived physical quantities. So the units used for the fundamental physical quantities are called fundamental units. The units used for the derived physical quantities are called derived units. Just now we have seen in table. In table we have seen all the fundamental quantities and their units. 7. Of course, 8, 9 also there. You learn in the lower class, 6th class. Plane angle is measured in radian. Solid angle is measured in steradian. Similarly, derived physical quantities also measured in. So when you come to the unit part, unit also divided into fundamental units and derived units. Unit is nothing but standard measurement of any physical quantity, which is measured. The units used for the fundamental quantities are called fundamental units. kg, meter, second, candela, mole, Kelvin. All these are comes under the fundamental units. Whereas the units used for the derived quantities are called derived units, like meter per second square, Newton per second, right? Newton per meter square. All this. See, here one more table is given to know about the derived units. See, so derived quantities are what? Area, volume, density, velocity, acceleration, force, pressure, work, power. So many you can write here. So area is nothing but what? First, if you see formula, you should know length into breadth. So length is measured in meter, breadth also measured in meter. Meter into meter, meter square or square meter. The square meter is known as derived unit of area. Similarly, volume. Volume is length into breadth into height. So meter, length also fundamental, breadth also fundamental, height also fundamental. Meter into meter into meter, meter cube or cubic meter, m cube. Right? Clear? So the unit used for the derived quantities are called derived units. Similarly, when you see the density, density is nothing but what is density? Mass by volume. Mass by volume. Mass is a fundamental quantity. Volume also derived from fundamental quantity. So mass is measured in kg and volume is measured in meter cube. Kg per meter cube is a unit. Similarly, for velocity, displacement by time, meter per second, force, acceleration, meter per second square, force, there are some new force is equal to mass into acceleration, formula is given and common unit is, special unit is Newton. Like that, these are only few examples are given. You can find so many derived quantities. For all derived quantities, you can write the derived units if you know the exact formula. So remembering formula is very important. If you know the formula, you can write the units of the derived quantities, which are called derived units. Right? You can note down all these in your notebook later, and you can add so more also. Whichever you are coming across your regular chapters of mathematics or physics, you can add and you can write their formula and units. Right? Clear? So we are completed with the what is unit, what is fundamental units, what is derived units, and you have seen the two tables. One is for fundamental units and second is for the derived units and derived quantities. Then another important basics which already you learned in 6th class but need to recall, system of units. So the fundamental units of length, mass and time has taken together to form a system of units. To form a system of units, they taken the mass, length, time as a standard. For measuring the various physical quantities, following systems are commonly used. You can see table again. One is MKS system, CGS system, FPS system. Meter, kilogram, second. Centimeter, gram, second. Foot, pound, second. So different countries use different systems, and they are main as CGS system, MKS system, and FPS system. And after that, there is another system came, SI system, Standard International System, to maintain the proper business dealings with the countries. So in around 1965 to 71, between, they finalized the one common system called SI, International System or System of International. Okay, there is also fourth one. It is called SI system. So these are all together called as system of units. Right? You can see here FPS, foot, pound, and second system. Time is common in any system, seconds only, standard unit. CGS, centimeter, gram, second. MKS, meter, kilogram, second. Right? Clear? Okay. Now, very important point is, when you are writing the units, there are some guidelines you have to follow. When you are writing the units, you have to follow some guidelines. It is very important when you go to the competitive exam level, like IIT and all. You know what unit, you know how to write it. But before writing the unit of any physical quantity, you should follow some guidelines. See, the symbol of unit which is not named in the honor of some scientist is written in small letter. Example, you can see turn. Suppose any unit which is not named after scientist, because there are so many units which are named after the scientist. Right? Example you can see here. The symbol of meter. Meter is not name of scientist. So you can represent only by small letter. Meter. Because it is not named after the scientist, we represent by a small letter M. Means any unit which is not named after the honor of the scientist can be written with a small letter. Meter. Second. Gram. Gram you are right like this. G. Not capitals. Second also yes, small yes. Right? Next, second point. The quantity of unit which is named after the honor of the scientist is written in the capital letters. Suppose Newton. You know, Newton is the name of the scientist. You can write as symbol if you want. N, capital N, 10 Newton. The force is equal to 10 Newton. We cannot write 10 Newtons. Named after scientist, Newton, Pascal, Watt, Kelvin, Celsius. All these are the name of the scientists. We are using the units with the honor of the scientist. In such case, you have to use the capital letters. If it is not name of the scientist, symbolically represented by small letter. If it is the name of the scientist, represented by capital letter. Remember that. You lose the marks in competitive examination. See, Joule, J, Newton, right? Celsius, N. All these are represented. When you symbol of power, Watt, W. What is the name of the scientist? That is for symbol. When you are representing symbolically, these are the rules. Two ways. Symbolically, you are representing a unit not honored with scientist name, unit honored with scientist name. Not honored is small letter, honored is capital letter. Symbols. But when you are writing full name, when you are writing full name of the unit named after honor of scientist is written with the lowercase letters. Suppose we are writing, you want to write 10 newtons. So write small letters on Newton. When you are writing, want to write symbol, you have to write capital letter. When you want full name, you can write small letters, so lowercase letters. Right? You should not write capital here, not capital. Only you have to write newtons like this. Don't write S also, because there is only 1 Newton is there. Whether it is 100, 10 or 100, write only Newton. Should not use the plural. Some conditions they are. Right? That is one point. Next, when you say fifth one, a compound unit obtained by multiplying 2 or more units is written after the putting a dot between the individual units or leave space between the individual units. For example, force into time is there. It is called impulse actually. So force is measured in Newton, time is measured in second. Don't write NS. Either give N dash S or N dot S or N leave some space in S. Newton second, watt meter. Something like we'll get. See here example. Newton second, Newton meter. Right? So when you're a unit is a combination, compound. Newton is 1 unit and second is 1 unit. When you are combining them, there is a compound unit that is called. When you are writing compound units, what you have to do? You have to give space between the 2 symbols. Or put the dash or put the dot. Right? Clear? Very important point. And next, negative powers are used for compound units obtained by dividing 1 unit by another unit. When you are dividing 1 by another, we'll get, for example, meter by second, we'll get, you can write as meter second inverse minus 1. Because this, when S comes to numerator, it becomes minus 1. See here, meter per second as written as ms minus 1, ms minus 2 for acceleration, Newton meter minus 2. That you are represented by minus. Either you can leave like this only. If not, when you want to take this numerator, you have to use minus 1. Suppose Newton second is there. You can write Newton per second. You can write Newton second minus 1. So meter per second square acceleration. You can write meter second minus 2. Then square comes numerator minus. Just mathematics, simple mathematics. Right? That is one point. A unit in the short form is never written plurals. Should not write in plurals. Suppose 30 kg also. You cannot write kgs, no need. Kg itself is because already it have values there. Or grams, you cannot write GMS, only GM. 100 or 1000, whatever it may be. So, very important. These are the most important 6 points. Most important points you have to follow. The guidelines you have to follow before writing the units. This is keenly observed in the competitive examination. Because in multiple choice questions, they give the different, all are look same. But which one you are choosing is very important. Right? All they are the same only, almost. But which one you select is very important. For example, see, the unit of mass is, they will ask. For example, I am telling. Number 1, A. Right? Gram. B. Gram. C. Gram. D. None. We know mass is measured in gram or kg, no problem. But which one you have to select? It should be small letter. Symbolic representation. This is not wrong. This is wrong. This is also not wrong because it should be used small letter. Like that, you can get the, you'll get the confusion where to use. For that, you should know all the 6 points. So these 6 points you can copy in your notebook, please. So guidelines, just citing as guidelines. Guidelines to write unit. Guidelines for units, bracket you can write. In notebook and mention all the 7 points, one example. No need of writing all 3, one example you can write. Very, very, very important in the part of unit part. When you are learning about unit, these are the basics you should know. Right? So I request the teachers, please check whether students are completed or not. And after that, you can go for your initial. Very important points, very important things. So before going for any additional information given here, just I'll show a small video regarding the same system of units. A small video, just 2 minutes video to know about the system of units. Just see that and then we'll come back to the class.
Units. A complete set of units, both the fundamental units and derived units, is known as the system of units. In earlier time, scientists of different countries were using different systems of units for measurement. 3 such systems are FPS, British System, CGS, Metric Absolute System, MKS, Metric Absolute System. Units for these 3 systems. Units: system, length, mass, time. FPS, foot, pound, second. CGS, centimeter, gram, second. MKS, meter, kilogram, second. SI system. The system of units, which is at present an international acceptance for measurement, is La Système International des Units. It abbreviated as SI. Uses of SI. As SI units of length and mass make use of decimal system, conversions within the system are simpler and more convenient. For international usage in scientific, technical, industrial, and commercial work, the SI units are widely used. Fundamental quantities in SI. Fundamental base quantity, unit, symbol. Length, meter, m. Mass, kilogram, kg. Time, second, s. Electric current, ampere, A. Thermodynamic temperature, Kelvin, K. Luminous intensity, candela, CD. Quantity of substance, mole, MOL. Supplementary fundamental quantities in SI. Plane angle, radian, rad. Solid angle, steradian, SR.
Right. So this is the total information about the simple, a small video about the right. Knowing about what are the system of units, what we already discussed. I don't know why this is not. So after that, we have seen the what is the. Yes, something is hanged here. So you have seen what are the rules or what are the guidelines to be followed for writing the units. There are 6 important guidelines are given. 7 important guidelines are 6, 4, 5, 6 only. You note all the 6 guidelines and follow the lines when you are writing the units either in physics or in chemistry or in mathematics also. When you are writing the units, you must follow them, right? So there is some issue here. Let me. Anyway, then some additional information is there here. You can see there is some additional information regarding the. Just a minute. Let me. This system is hanged. Can you hear me? there is some technical issue. Okay,